Hi there, welcome back. In this screencast I'm going to be telling you how to use keras and R to fit neural networks of different sizes and to see how to demonstrate overfitting with those different neural networks. So what we have here is a data table here of 1,000 rows with different values of the validation and train loss and accuracy for single layer neural networks with different numbers of hidden units in a single hidden layer. And so we've trained each one for 100 epochs on the spam data, and we see so this is what the plot looks like for when the number of hidden units is 128. And so what we want to do now is we want to visualize all of these numbers together to see what they look like. So let's do that using a ggplot. So here I'm going to do library ggplot2 to start ggplotting. And then I'm going to use ggplot plus geom_point. Or actually, let's do geom_line so you can emphasize the continuity, if you will. Geom_line. And so here what we're going to do is give an aesthetic mapping x, which is the number of epochs on the x-axis. Y equals the val loss, because that's what we're interested in minimizing. And let's say let's say color equals hidden units. So let's take a look at what that plot looks like as like a first pass data visualization of everything. So we're not looking at train validation. We're just looking at the validation data. And we're just looking at the loss, not the accuracy. So let's take a look at that. Units, metrics. So what this looks like is, I don't know, it looks like I probably need another group equals hidden units. It looks like, yeah, there we go. So that means to draw a line for each different value of hidden units. So what we can see is that, well, actually, since we did the data on the log scale, we might think about doing log 10 for the color scale to see like kind of a more equal distribution of colors. And then we might think about using a different color scale scale color, gradient. Let's see, scale color gradient. Low equals gray, high equals red. Let's try that. And let's do a theme BW to get a black and white white background instead of black background. Okay, so here's what we see. We see that the low values, so here this is what it looks like for 2 hidden units. The validation error looks like it's going down, but it's not ever going back up. With some of these other curves, it looks like it's going down, maybe going up again. And then when we start to get a lot of hidden units, it starts to get pretty noisy. The dark reds are going to be the values with lots of hidden units. So another way to visualize this data, instead of putting them all on the same plot, you might think about doing a ggplot where we have instead of different colors in the same panel, we think about putting them all in different panels. So to do that, we get rid of color and group here, and then we add a facet wrap on hidden units. What that's going to do is going to draw a different panel for all of the different values of the hidden units. so we can see maybe a little bit more clearly how the curves look different as a function of the number of hidden units. Again, this is the validation loss that we want to minimize to figure out the best number of epochs. And so, what we see here is the, well, it starts out, by having some curve that looks like this. It starts out high and just goes down. And already after about only 8 hidden units, it looks like it goes down and goes up a little bit again at the end. Here at 16, it's still pretty slight, but once we get to about 6,428 hidden units, it's pretty clear that you get a minimum like somewhere in the middle, and then it's going back up again. And what's interesting here is that you can see that there's different values for the minimum, right? So here, it seems like it's hovering more or less around 0.4 for the first 3 here. Going up to 16 hidden units, for some reason, it doesn't quite get down to 0.4 validation loss. And maybe, I'm not sure, I mean, one thing that's a little bit confusing here is that we're only doing one train validation split each time, and we didn't fix the validation set. So we're not quite clear whether or not these numbers are comparable, because all of these different ones came from different validation sets. So one thing that we should probably do in order to have a more clear comparison between all of them is to actually pass the validation set ourselves, so we can kind of control for that randomness. So we control that random train validation split instead of having that as like a compounding variable in our analysis. So yeah, I guess we can do that in the next screencast. So thanks for listening.